Hello everyone, in this video we're going to talk about problem statement and customer need. So the engineering design process is shown here on the right side. So we start the design by defining the problem, then we are going to develop the specification for our designs. We're going to generate some concepts, then we are going to select the best concept, and then we're going to go through prototyping, which is mainly 3D printing that we covered. Then we do the testing. So when you do your design, you design your S hook, we are gonna do the testing. Then we are gonna make modification, and then we'll have our final design. Sometimes you have to go through this process several times, go back to the drawing board and modify our designs. But here in this lecture, we're gonna focus on defining the problem. That's the critical aspect of the design process and what the customer needs. So let's look at an example. Here the problem statement is indicating we are going to design a cheaper incubator for neonatal infant in developing countries. So that's a good problem statement, and we're going to cover why this is a good problem statement. So here you can see an incubator, and the incubators, well, this is a simple incubators, but some advanced ones could be very expensive, and then in developing countries they can't afford it. So what would be the solution? Based on this problem statement, it doesn't tell us how to do it. It just we want something that would have the needs of our infants, and it would be cheaper for us. So the solution can be as simple as a heated blanket, and that would satisfy our requirement. In here you see a lot of heat, going away from the head. Normally the head should be covered, but that would be a simple solution to the problem. In designing the problem, we need to have three things in mind. First is the function. What function needs to be done? Then the customer. What does the customer, client, or user want? We need to identify our customer. Who is our customer? Then the realistic constraints. So depending on the design, we would have economic factor, safety, reliability. These are the factors that are normally present in almost all the design process. But remember these three things that your problem statement needs to have. Let's look at another example. We are going to design an MRI for children, because MRI could be scary. It's very enclosed, it's not really open, you could get claustrophobic, and the whole process could be scary. But who is our customer? Well, we are designing MRI for children. So can we say children are our customer? Or the hospital, because the hospital is paying for it. Or maybe the technician who is using it and has to deal with this. So who is the customer? Is it the one who is going to use the product? Is it the one who is selecting the product at the end? The one who is paying for the design? Which one do you think is our customer? And the answer is that all of them. We could have different layers of customer, and when we are designing, we need to keep that in mind, that we have to satisfy different needs and different layers of the customer. But what would be a good problem statement for this? Can we say we are going to design a new MRI machine that is wider, or design a new MRI machine that is not enclosed, or maybe design an MRI machine that does faster imaging so the children don't have to stay there longer? All these three are not good problem statements because they talk about how. If we say that we need an MRI machine that is wider, then it limits us. We have to design something that is wider. But the idea is not that. The idea is that we want to have just an MRI experience. It could be anything. It could be wider. It could be not enclosed. It could be faster. But we're not going to limit ourselves. So the fourth one is the right problem statement. We're going to design a new MRI experience for children so that they are not scared, whatever that would be. So let's look at the solution. Pirate Island. So basically we didn't change anything. We didn't change the MRI width or imaging process, and just created a different experience. That's as soon as the students get in the room, they are going through different process. They play a game, and then part of the process they have to get on this rail and then go inside, and it's a totally different experience. And we haven't, that was the simplest solution that we could find. So in our need analysis process, we need to collect data from the users or the customers. Then we need to interpret those raw data, which is very important for us, organize them, then find out which ones are more important, then think about the result and see if we need to go back and collect, more data. But how can we collect raw data? Simply by asking the users and customers. We need to interview them and interview them for 1 or 2 hours. Just try to understand what they want. We could do 10 to 50 separate interviews to get really a wide range of customers. Focus groups are nice because people bounce ideas off each other, but it's typically expensive. You have to pay them. Online surveys, anonymous surveys. So if the topic is sensitive and people are not comfortable with sharing their real opinion, then anonymous survey would be helpful. And last but not least, observe the product. If you are designing a process, redesigning a process for a company, you need to go and see the process firsthand to see what's going on. And then you would have a better idea in the design process. So going and seeing it, let's say you're designing an MRI, you need to go see the MRI machine. A couple of important factors is that we need to avoid biasing in our discussions. We need to look into the unspoken needs, basically those latent needs. And it's a good practice that if one person asks a question and the other person writes down the notes. We don't want to reject any ideas at this stage, because then it's just going to block the users to share their opinions. If we have any visual that we could take so the customers can point at it and deal with it, that would be better. Here is a video of a focus group about what features the users would like to see in their desired car. So please pause the video here and go watch this focus group video on YouTube. The link is on the lecture, so if you're following the lecture from the PowerPoint, you can simply click on it and it would take you to that focus group. It's very important for you to watch it so we can talk about the rest of the lecture. So pause this video here, go watch this video, and then come back to this lecture. So in that video, you would see that the customers say their opinion about their desired car features. You will write down everything that the customer says, Bluetooth capability, voice activated lights, and everything. Your job is to just write it down. At this stage, some of the ideas might not be even feasible. Some of the ideas are conflicting. Someone says that they want the car to be too small. Someone says they want the car to be too big. Our job is to just collect raw data. We are not judging or thinking about the solution. It's very important that we don't shoot down any idea, because then the customers and users are very careful what they're gonna say. They want to just say things that it sounds smart. They don't want to be humiliated. So we do not shoot down ideas. Doesn't matter how strange it is. If you have watched the video, you know some of the ideas are really strange, but we are gonna write it down, and then later on we're gonna go and sort conflicting ideas, unfeasible ideas. However, we are not gonna shoot down the ideas, but we can ask follow-up questions. Why do you want the car to be too small? Maybe they want it to feel secure. Maybe they don't want anybody else to sit in the car. They want to limit who can ride in the car. In the video, the guy says that I want the car to be stinky. Well, then when you ask them, then they're gonna retract that statement. So, okay, that's fine. Then the important part is that we have the customer needs, that they say what they want, and then what we need to extract the need statement, something that we use for our design process. So this is a good table structure to have for your report as well, to just write the customer needs and then develop the need statement. Let's look at some of the need statement. The customer says that I want Bluetooth capability. Well, the need statement could be simply the customer statement, the car has Bluetooth capability, or the car has an ability to communicate with smartphones. Basically, the customer doesn't care how it is connected. They want their phone to be connected to the car. Maybe Bluetooth, become obsolete at some point. So what we really want is the car to be able to communicate with the smartphone. So this is the true need statement we extracted from customer statement. Let's look at another example. The customer wants voice activated lights. So what does that mean? Does it mean the car needs to have a microphone to hear the driver? Maybe the lights of the cars are voice activated? Or better, the car has features activated hands-free. So that's what the customer wants. The customer doesn't want to turn different knobs in the car to turn on the light. They want it to just be done, hands-free. Or maybe even better, the car turn on automatically when it gets dark. That's what the need statement that we got it from the customer statement. The customer wants automatic side view mirror. That's one of those things that we need to identify and ask follow-up questions to find out what the customer actually wants. The bad need statement is just writing the customer statement. The car has automatic side view mirror. But do we want to minimize the width of the car while parked, like these trucks that the side view mirror just folds? Or maybe by automatic side view mirror, we are talking about the blind spot. So it has a flashing light when another car is next to it. Or we want the mirror to have a motor to turn them. Again, this talks about how to do it, and this is not really good. So need statement 2 and 3 could be the proper need statement for that customer statement. One thing we need to focus on is that our problem statement, our need statement, has to deal with the function, what the product must do, not how to do it, because how is just going to limit the solution that we are going to provide. And then it forces us to just follow that solution and nothing else. We want to allow for more potential solutions. So that's what we need to keep in mind. Let's look at this example. We are going to redesign connector to prevent flow of imaging solution to saline supply. So here's an IV that goes to the patient. Usually it has one end, sometimes it has two ends. That's the saline that goes in to the patient body. And then when you want to put imaging solution, if you want to take an MRI or other imaging, they do an imaging solution so you can see better. So it comes into this connector and goes to the patient. But the problem is that when you put the imaging solution, sometimes it goes up. So it goes up and it goes to the patient. And that's not something really desirable. So the problem statement says that we want to redesign this connector. But in reality, we don't have to say what connector, because that's the solution. We're going to be more general. Redesign system to prevent flow of imaging solution. And you know what the solution is? Normally they use these are the locks. So if you don't want to go up here, you just lock this. Simply push this and this one is locked. And the imaging solution goes in here. So if we had just called it redesign connector, we had to focus on this. We had to focus on redesign the connector. And we would not have been able to provide this solution here that just put a lock here. So by calling it system, it gives us a more flexibility. We don't call it how, we're just saying what. Or in the video, there is a guy who keeps saying a good steering wheel that doesn't fly off while you're driving. So what is the need? If we say strong bolts, we are talking about how. If we say rugged, it's very vague. We try to avoid these vague words that we don't know exactly what we mean. Then the best one would be that the steering wheel remains attached regardless of driver-induced forces. That's the whole point. That's what it needs to do. How, then we can decide it in our concept generation. Couple of points is that we are going to use positive phrasing, not negative. We don't want to say doesn't fly off. We want to say that remains attached. We want to talk about the attribute of the product. Instead of Bluetooth can be used, we're talking about Bluetooth capability. We don't want to use the word must and should, because the word should means that it's better to have it, but it's up in the air whether it needs to have it or not. A must, it just gives an urgency, just implying that this is more important than anything else than other part of the specs. So these should and must are not really helpful in our need statement, and we try to avoid them. Then after following that, we need to go to the realistic constraints and see that what realistic constraints we have in terms of economic, environmental, sustainability, reliability, manufacturability, durability, and so forth. And most designs have all of these. So let's look at the customer statement. Again, a great steering wheel that doesn't fly off while you're driving. Which realistic constraint would the customer is prioritizing now? Is safety. That's what they're caring about. And we have to identify that. So there is a teamwork activity here that each group needs to select one topic here out of these 8 topics, out of these 8 challenges, and then go through developing your problem statement. After you choose your topic, then you need to do an interview. You need to interview 4 or 5 potential customers. You're going to write down the question you ask. You need to come up with the question based on the topic, and then you need to write down the answers. There could be more than one answer to each question. You could do a focus group. That would be an extra credit. Focus groups are really harder, and you have to do a recording of the focus group. And like the one in the video, just watch that video and see the focus group and include everything in your report. Potential question is always, what do you like about the product? What don't you like about the product? Why do you think is how it needs to perform? But you could come up with any question that you need to have. And remember, there is more than one answer for each question. You're asking multiple people, so you could write all the answer, or one person could provide more answers. Then you need to develop, that's the important part of it, to go from customer statement to the interpreted need or need statement. And we have to write down the need statement for each case. The need statement, this is a checklist you need to remember. Not talking about how to do it, just what to do it. We want to use positive phrasing, specific language. Write everything as an attribute. Avoid using must or should. Then we're going to have a realistic constraint. So develop your need statement for realistic constraint. Let's say you're designing a car. What would be the economic realistic constraints? The economic would be the car is affordable. The design is green and produces no pollution. So there is a lot to do in this part. You need to make sure that you assign tasks to each team member so they can complete it. Then at the end, the last task is to develop your problem statement, like redesigning the MRI experience for children to feel comfortable and secure. Design and manufacturing of, let's say, thermoset continuous fiber 3D printer. It needs to be 12 words, but you need to be very careful of how you select these words. And that would be the last part of this assignment.